Astronomers have already confirmed 9 oddities about 3I Atlas, but the 10th is different. It's the one that makes even the calmest scientist uneasy. Somewhere near the Sun, this interstellar visitor accelerated. Not from gravity, not from outgassing, but from something else. Every model says such a maneuver would demand chaos, a massive outflow, a debris cloud taller than Mount Everest, billions of tons of dust and vapor thrown into space. Yet the telescope saw nothing. No plume, no fragments, just silence and motion. And if between November and December of 2025, follow-up observations still find no trace of that missing debris, then 3I Atlas will have done something no known comet has ever done. Changed its path through space without losing a single ounce of visible mass. A force without a cause, a movement born of nothing. Stay with me until the end as we dig deep into this 10th anomaly, and shockingly, the one no one's talking about. Because if it can change its course once, what's to stop it from changing it again? Maybe toward us. If this mystery pulls at you the way it does me, don't just watch from the shadows. Join the chase. Hit like and subscribe so you don't miss what happens next, because this story is still unfolding in real time. Tell me where you're watching from, what time it is there, and what you think about this 10th anomaly. And if you want to help this community grow, share this video on X, Facebook, Reddit, or even just in your group chats. You're the reason we can keep chasing stories like this. So, thank you for having our back. Part 1, the reveal. Imagine an object from another star system hurtling through our solar system at speeds that make a bullet look like it's standing still and doing something no known comet can do. You're probably thinking, another weird space rock, another clickbait headline. But here's the thing. This one is different, and the reason it's different will keep you up at night if you let it sink in properly. The object has a designation that sounds like a password reset code. 3I Atlas, that's 3I Atlas to you and me, where the I stands for Interstellar. The third confirmed visitor from beyond our solar system. The first was Oumuamua, which already had everyone arguing about whether it was a comet, an asteroid, or something else entirely. The second was Borisov, which behaved like a nice normal comet and made everyone breathe a sigh of relief. See, we said the universe is just the way we thought it was. And then 3I Atlas showed up, and the universe said, not so fast. Here's what you need to understand right now before we go any further. This object has 9 confirmed anomalies. 9 separate ways it's breaking the rules, bending probability, making astronomers scratch their heads and double-checked their math. We'll run through those in a moment, but first, I need you to focus on what nobody is talking about yet. The 10th anomaly, the one that takes this from extremely weird to we might need to rethink everything we know about how objects move through space. The 10th anomaly is this. 3I Atlas appears to have undergone a non-gravitational acceleration near perihelion, its closest approach to the Sun. Let me say that again differently. The object changed its speed and direction in a way that gravity alone cannot explain. Now, comets do this all the time. They heat up, they outgas, they shed material, they get a little rocket push from all that venting ice and dust. It's normal. It's expected. Except here's the problem. If 3I Atlas accelerated the way the measurements suggest, it should have ejected more than 5 billion tons of material. 5 billion tons. That's not a typo. And when a comet sheds 5 billion tons of ice and dust and rock, you see it. You see a massive glowing debris cloud. You see tails stretching across the sky. You see brightness spikes. You see evidence. And so far, we're not seeing it. Not at the scale we should, which means one of 2 things is true. And I'll be honest with you, neither one is comfortable. Either we're missing the debris cloud for some reason, which would make this an exceptionally strange but still natural comet, or the object accelerated without shedding the expected mass. And if that's true, if that second option is what's really happening, then we're dealing with something that violates our understanding of how momentum and mass work. Something that changes direction without throwing material in the opposite direction. Something that moves like it has a plan. To truly grasp the profundity of the 10th anomaly, we must first understand the context. the 9 other ways 3i Atlas has already broken the rules, bent probability, and forced scientists to double and triple check their data. These are not wild speculations. They are peer-reviewed, measured, and confirmed weirdnesses that set the stage for the main event. First, its trajectory. 3i Atlas came screaming into our solar system on a retrograde orbit, meaning it moves opposite to the direction of nearly everything else, a cosmic rebel. But bizarrely, its path is also unnervingly aligned with the ecliptic plane, the flat disk where our planets orbit. The odds of a random interstellar object achieving such a precise alignment? A mere 0.2%. Unlikely, but not impossible. Yet this is just the beginning. Second, the timing of its passage was a masterclass in celestial choreography. It passed near Mars, then Venus, then swung by Jupiter's gravitational influence, all within a highly improbable window. Simulations suggest the odds of this specific sequence occurring by pure chance are less than 0.05%. When you start stacking these low probability events, you begin to wonder if you're witnessing a random coin toss or a carefully orchestrated maneuver. Third, its sheer scale and speed set it apart. It is larger and faster than its interstellar predecessors, Oumuamua and Borisov, moving with a purpose or a momentum that suggests an unimaginably long journey through the galactic void. Fourth, its chemical composition is all wrong. Spectroscopic analysis reveals gas ratios that are extreme outliers. The nickel-to-iron ratio, the nickel-to-cyanide ratio, they don't match anything we see in our own solar system's comets. It's as if this object was assembled using a different recipe book, one written in a far-off stellar nursery with conditions we can scarcely imagine. Fifth, and critically, its water content is bafflingly low. Most comets are dirty snowballs, composed largely of water ice. 3i Atlas, by contrast, is only about 4% water by mass. This isn't a dirty snowball, it's something else entirely. A carbon dioxide-dominated entity that formed in an environment where water was a scarce commodity. Sixth, the polarization of light scattering off its surface is unprecedented. It exhibits extreme negative polarization, a fingerprint that doesn't match any known comet in our databases, suggesting the particles around it are either impossibly small, shaped bizarrely, or made of a material we've never encountered. Seventh, its brightness and color behavior are backwards. As it approached the Sun, it brightened faster than any comet on record, and instead of reddening like all others do as dust dominates the reflected light, it turned a profound, brilliant blue, bluer than the Sun itself. Eighth, it displayed an anti-tail, a jet of material seemingly pointing toward the Sun, defying the solar wind and radiation pressure that always push comet tails away. While sometimes an illusion of geometry, evidence suggests this was a real sun-facing ejection, a phenomenon that challenges standard comet physics. Ninth, and perhaps the most spine-tingling coincidence, it arrived from nearly the exact same celestial direction as the famous, never-explained WOW signal detected by SETI in 1977 within a mere 9 degrees. The odds of that? The universe seems to be screaming a message we are only just beginning to hear. These 9 anomalies form a constellation of weirdness, a prelude to the main act that makes the 10th anomaly not just another data point, but the keystone that holds this terrifying arch of mystery together. Now we arrive at the heart of the terror, the anomaly that transforms 3i Atlas from a scientific curiosity into a potential paradigm-shattering event. The 10th anomaly is this. 3i Atlas appears to have undergone a significant non-gravitational acceleration near its perihelion, its closest approach to the Sun. Let me be perfectly clear, the object changed its speed and direction in a way that the gravitational pull of the Sun and planets alone cannot account for. Now comets do this regularly through outgassing. They heat up, ice turns to gas, and the ejection of that material acts like a natural rocket engine, nudging the comet along. It's normal, expected, and governed by Newton's third law. For every action, there is an equal and opposite reaction. But here is the catastrophic problem at the core of this mystery. If 3I Atlas accelerated the way the precise astrometric measurements from instruments like the ALMA array suggest it did, it should have ejected over 5 billion tons of material. 5 billion tons. That is not a typo. It is a staggering amount of mass equivalent to a small mountain being blasted into space. When a comet undergoes such a cataclysmic shedding of itself, it is a spectacular, unmissable event. You see a massive, glowing debris cloud that can stretch millions of kilometers. You see brilliant tails dominating the sky. You see the comet's brightness spike to extraordinary levels and remain there for weeks. You see evidence, and so far, with all our eyes in the sky, we are not seeing it. Not at the scale required. Not even close. This leaves us with two stark and frankly uncomfortable possibilities. Either we are, for some reason, completely missing a debris cloud of biblical proportions, which would make 3I Atlas an exceptionally strange but still natural comet, or the object accelerated without shedding the expected mass. If that second option is true, then we are facing something that violates our most fundamental understanding of momentum and mass. We are looking at an object that can change its direction without throwing material in the opposite direction. It is, for all intents and purposes, a cosmic rocket that appears to have no exhaust. This is the equivalent of watching a car accelerate down a highway with no engine noise, no exhaust fumes, just silent, inexplicable motion. It is a red flag of the highest order, pointing toward either a gaping hole in our comprehension of physics or something far more deliberate. What is truly at stake with the resolution of this mystery? Why should anyone care about the trajectory of a distant chunk of ice and rock? The answer is that this is about more than just one object. It is about the foundational principles of our reality. Science is a process of questioning, of building and testing models against the cold, hard data of the universe. Sometimes that process leads to comfortable truths. Other times, it leads to revolutions that shatter our worldview. The case of 3I Atlas is one such potential revolution. If the follow-up observations in November and December of 2025 reveal the missing debris cloud, a massive, luminous tail and coma consistent with the ejection of 5 billion tons of material, then the mystery is solved. We will have discovered the most extreme natural comet ever observed, a testament to the incredible diversity and strangeness of the universe. Our physics remains intact, albeit stretched to its limits. We will have learned a profound lesson in cosmic humility that formation processes around other stars can produce objects far wilder than we ever imagined. This is scenario A, the conservative and most widely expected outcome. But if the observations do not show the debris cloud, if the telescopes point toward 3I Atlas and see only a modest coma, a faint wisp of a tail utterly insufficient to explain the observed acceleration, then we are thrust into scenario B, a territory of deep uncertainty. We are then forced to confront a much darker, more thrilling set of possibilities. Either our understanding of physics is profoundly incomplete, and there exists a natural mechanism for propulsion that we have never before witnessed or conceived of, or we are looking at something that is not entirely natural. This is not a jump to conclusions. It is a logical progression of inquiry. An object that can change its momentum without the commensurate reaction mass is the ultimate scientific anomaly. It challenges centuries of established mechanics. For planetary defense, the implications are immediate and alarming. Our entire early warning system for asteroids and comets is based on predictable gravitational orbits. If objects can accelerate unpredictably without visible cause, then our ability to protect our planet from impact has a fundamental and potentially catastrophic blind spot. You cannot defend against a threat whose path you cannot predict. Let us delve deeper into the weeds, into the very substance of this visitor, because its composition is where the weirdness first began to scream for attention. When the James Webb Space Telescope trained its infrared eyes on 3I Atlas in the late summer of 2025, it read a chemical barcode that left scientists stunned. The carbon dioxide to water ratio was an almost inverted 8.1. For context, comets in our solar system are typically dominated by water ice, with carbon dioxide as a minor component, often with ratios of 10:1 or even 100:1 in favor of water. 3I Atlas is a carbon dioxide comet with a mere sprinkling of water. This suggests it formed in an environment that was incredibly carbon-rich and water-poor, a place unlike any region in our own solar system's formative years. Furthermore, the water that is present is behaving oddly. Its production rate is far lower than expected for an object of its size at its distance from the Sun. Then there is the polarimetry. The way light scatters off the particles in its coma shows an extreme negative polarization, a signature that is literally unprecedented in the annals of comet science. It tells us that the dust and ice grains surrounding this object are not the familiar mix of silicates and organics we see everywhere else. They are something alien, perhaps pure carbon dioxide ice grains, or radiation-processed organic polymers, or metallic particles with bizarre shapes. Most tantalizing and still unconfirmed are preliminary spectroscopic hints of unusual metal ratios, specifically an enhancement of nickel relative to iron. In our solar system, nickel and iron are found in cosmic abundance ratios, about 1 part nickel to 16 parts iron. The whispers from the data suggest 3I Atlas might have ratios closer to 1.1 or even nickel-dominated. While this must be treated with extreme skepticism as the signals are faint, the mere fact it is being discussed by serious scientists is telling. Nickel-rich alloys are what you find in industrial processes and refined aerospace materials, not in naturally condensing protoplanetary disks. This composition, when taken as a whole, paints a picture of an object that is not just an outlier, but a true alien, formed under conditions so foreign that they might as well be from a different universe. It is a chemical red flag waving frantically alongside the dynamical red flag of its inexplicable motion. Orbits are the immutable history books of celestial objects, and the trajectory of 3I Atlas tells a story that is deeply suspicious. It arrived on a hyperbolic path, eccentricity 1, confirming its interstellar origin. It moves retrograde, which is not unusual for an interstellar visitor, but its orbit is aligned within about 5 degrees of the ecliptic plane. In a 3-dimensional universe, the probability of a random object achieving such a precise alignment with our solar system's disk is a mere 0.2%. Then consider the timing. It passed near Mars on October 4, 2025, then near Venus on October 10th, reached its scorching perihelion on October 29th, and then passed near Jupiter's orbit in early November. This sequential close passing of 4 major solar system bodies in a matter of weeks is astronomically improbable. Simulations place the odds of such a precise choreography at around 0.05%, or 1 in 20,000. When you multiply these small probabilities together, the combined odds become vanishingly small. But the most intriguing detail is the timing of its perihelion. This moment of greatest solar proximity and, for a normal comet, greatest activity occurred just 8 days after solar conjunction. This means 3I Atlas was hidden directly behind the Sun from Earth's perspective during its most dynamic phase. For about 2 weeks, it was in an observational blackout. This is awfully convenient timing if one were trying to perform a significant maneuver away from prying eyes. As some astronomers, like Harvard's Avi Loeb, have pointed out, the trajectory of 3I Atlas looks optimized. If you were designing a mission to survey the inner solar system, you would plot a course that takes you past Mars, Venus, and Jupiter. You would align with the ecliptic plane where the planets reside, and you might even schedule your most critical engine burn when you are hidden behind the Sun. This is not proof of design, but it is a pattern of fine-tuning that, when added to the other anomalies, becomes increasingly difficult to dismiss as mere cosmic coincidence. The photometric behavior of 3I Atlas as it approached the Sun added another layer of profound strangeness. Comets brighten predictably as they get closer to the Sun. It's a fundamental rule. 3I Atlas did not follow this rule, It brightened explosively, increasing in luminosity by several magnitudes in a matter of weeks between August and October 2025. This is the kind of brightening associated with a nucleus violently fragmenting, yet 3I Atlas appeared to remain intact. Even more bizarrely, its color changed. Comets typically redden as they approach the Sun because dust, which scatters red light more efficiently, dominates their coma. 3I Atlas did the opposite. It turned a brilliant, deep blue. This suggests its coma is not dust-dominated but gas-dominated, with carbon dioxide fluorescence potentially causing the blue hue, or its surface is an unusually reflective and smooth ice that scatters blue light. Then there is the matter of the antitail, the sun-facing jet observed before perihelion. While sometimes a geometric illusion, the data for 3I Atlas suggests this was a real event, material being ejected toward the Sun against the immense pressure of the solar wind. This is not how normal comet physics works. If you were to model this as a natural object, you would have to invoke a perfect storm of edge case conditions. A bizarrely low dust content, exceptionally high gas production, active regions in geometrically impossible locations, and a surface that behaves unlike any comet surface we've ever seen. The model would be strained to its breaking point. Conversely, if you model 3I Atlas as an engineered object using controlled thrusters or a propulsion system, these observations suddenly make more sense. You would expect jets that don't follow natural solar heating patterns because they are directed. You would expect a gas-dominated emission for efficient thrust. You would expect rapid, controlled changes in brightness as systems activate and deactivate. You would expect a blue glow from a specific propellant like carbon dioxide. Every single anomalous behavior shifts from being a random natural accident to a potential design choice. The cornerstone of the acceleration anomaly lies in the hard numbers of astrometry, the science of measuring celestial positions with mind-boggling precision. The Atacama Large Millimeter, Submillimeter Array, ALMA, a network of 66 radio telescopes in Chile, is one of the most precise instruments for this task. When ALMA measured the position of 3I Atlas near perihelion and compared it to the position predicted by purely gravitational models, it found a discrepancy of about 4 arcseconds. To the layperson, this sounds tiny. It's the width of a human hair viewed from across a football field. In the world of astrometry, it is a chasm, a canyon-sized error that screams, "Something is wrong." The first duty of science is to rule out errors and known effects. Could it be gravitational lensing? Einstein's theory of general relativity tells us that the sun's gravity bends space-time, deflecting the light from objects behind it. For 3I Atlas's geometry, the calculated lensing deflection was a small fraction of an arcsecond, an order of magnitude smaller than the observed offset. Could it be a measurement error? ALMA's data has been peer-reviewed and rechecked. Systematic errors of this magnitude are highly unlikely. We then move to other natural explanations. Radiation pressure? The force of sunlight on a solid, kilometer-sized nucleus is far too weak. The Yarkovsky effect, a thermal recoil force that acts on small asteroids over millions of years, it is negligible over a few months. Plasma interactions with the solar wind? Possible in theory, but the forces involved are minuscule unless the object has a powerful magnetic field, for which we have no evidence. Exotic, ultra-volatile ices like hydrogen or helium? They would sublimate at impossibly low temperatures and be gone in an instant near the Sun. One by one, the natural alternatives are narrowed down, leaving the uncomfortable, persistent reality of a non-gravitational acceleration with no visible commensurate cause. The upcoming observations are our final arbiter. They will search for the specific, testable signatures of each hypothesis, and in doing so, will guide us toward one of the possible futures. We now cross a line, moving from documented anomaly to reasoned speculation. If the December observations confirm the lack of a debris cloud, we are forced to seriously consider hypotheses we would otherwise dismiss. Option 1, we are still measuring something wrong. This is the human error hypothesis, embarrassing but salvageable. Option 2, there is a natural mechanism we have not yet discovered or understood, a new chapter in physics. This is the scientific revolution hypothesis, exciting but demanding extraordinary evidence. Then there is option 3, the object is artificial. This is the hypothesis that makes everyone uncomfortable, the proverbial elephant in the room. Let's be unequivocally clear, stating this possibility is not the same as endorsing it. It is an acknowledgement that if the natural explanations are exhausted, this hypothesis must be on the table. And if we explore it, a startling thing happens. Many of the anomalies begin to make a terrifying kind of sense. The optimized trajectory? Exactly what an exploratory probe would use to survey multiple planets. The carbon dioxide-rich water pore composition? Sensible for a stable, clean-burning propellant or coolant system, not for a primordial snowball. The nickel-rich hints? Consistent with advanced aerospace alloys. The acceleration without a massive debris cloud? The hallmark of efficient directed thrust, not chaotic outgassing. The brightening and anomalous jets, indicative of controlled systems turning on and off. The timing of the perihelion burn during solar conjunction? A logical point for a course correction when Earth-based observation is impossible, not necessarily for secrecy, but simply as an operational window. When viewed through this lens, 3i Atlas stops looking like a collection of random cosmic quirks and starts to resemble a coherent, engineered object. This does not prove it is artificial, but it shows that the artificial hypothesis is not absurd. It is, in fact, consistent with the entire suite of bizarre data. It requires technology that is only a few steps beyond what humanity is already developing with projects like solar sails and advanced propulsion. As we await the verdict from the cosmos, it is crucial to place this story in the context of our own technological ascent. In 2025, as 3i Atlas swings through our system, we are ourselves becoming an interstellar civilization. Private missions like Project Icarus II have successfully used solar sails to skim close to the Sun, harnessing radiation pressure to achieve incredible speeds and set course for the stars. Our own probes, though primitive, are beginning to mimic the behavior we are observing in 3i Atlas, using the Sun's energy to alter trajectory on hyperbolic paths. The irony is profound. As we search the heavens for signs of others, we are becoming the others. If a civilization 1,000,000 years more advanced than ours exists, its probes would likely be so sophisticated, so optimized for longevity and stealth, that they would be nearly indistinguishable from natural objects, revealing themselves only through subtle anomalies exactly like the ones we are documenting. Furthermore, the deployment of AI systems like the European Space Agency's Sentinel AI marks a new era in anomaly detection. These systems, unbiased and relentless, are now scanning the skies, flagging objects that deviate from known patterns. 3i Atlas was one of their first major flags. In the coming years, with observatories like the Rubin coming online, we will find thousands, perhaps millions, of new objects. Among them, there will be more interstellar visitors. If even a tiny fraction exhibit the same anomalies as 3i Atlas, the pattern will become undeniable. We are no longer passive observers of the cosmos. We are active interrogators, and the universe, through messengers like 3i Atlas, is beginning to answer. The question is, are we prepared for what it has to say? The final chapters of this story will be written not by us, but by the photons now traveling from 3i Atlas toward our telescopes. In December 2025, we will read them, and our universe will never seem the same again. As the final months of 2025 dwindle, the global astronomical community enters a state of focused, high-stakes vigilance. The timeline is no longer abstract. It is a concrete countdown to a moment of truth. December 19th, 2025 is circled in red. On every calendar, from NASA to the European Space Agency, from large international observatories to dedicated amateur astronomers in their backyards, this is the date of 3i Atlas's closest approach to Earth, bringing it within approximately 19 million kilometers, a stone's throw in cosmic terms. This proximity provides the optimal viewing geometry, the best chance to finally pierce the veil of mystery surrounding this visitor. The object will be traversing the constellation Pisces, a patch of sky that will become the most intensely scrutinized region in the universe for a brief, critical period. The world's most powerful telescopes, the James Webb Space Telescope, the Hubble Space Telescope, the ALMA array, the Very Large Array, and countless ground-based optical and radio telescopes have had their observing schedules meticulously cleared and dedicated. This is not a passive observation, it is a coordinated scientific assault, a multi-wavelength, multi-instrument campaign designed to capture every possible photon, every whisper of data emanating from 3i Atlas. The entire endeavor hinges on a single binary outcome, the presence or absence of a specific signature. The search is for the photometric, spectroscopic, and morphological evidence of that missing 5 billion tons of debris. The plan is exhaustive. Every day, new images will be analyzed for any sign of an extended coma or a developing tail. Spectrometers will dissect the light from the object, hunting for the molecular fingerprints of freshly exposed volatiles. Astrometric stations will track its precise position, confirming or refuting the continued presence of non-gravitational forces. It is a scientific trial, and 3i Atlas is the defendant. The evidence it presents in the coming weeks will determine its verdict: natural phenomenon or something that forces a fundamental rewrite of our textbooks. The scientific teams have a precise and detailed checklist of observables, specific signatures they will be hunting for in the data stream from their instruments. First and foremost is extended morphology. They will be looking for any change in the structure of the coma. Has it expanded significantly since perihelion? Are there visible jets, spiraling structures, or streamers emanating from the nucleus? Most critically, is there a clear, unambiguous dust tail stretching away from the Sun that was not present before? The absence of such a tail, given the claimed acceleration, would be the first major blow to the natural outgassing hypothesis. Second is photometry, the precise measurement of brightness. The teams have calculated exact light curves predicting how the object's brightness should behave if it were shedding a mountain's worth of material. They will be looking for a sustained, high-level brightness, specific color changes that indicate the composition of the ejected material, whether dust-dominated red or gas-dominated blue, and any rapid variability that could indicate rotational modulation or explosive jetting. If the brightness remains flat or follows a curve inconsistent with massive mass loss, the mystery deepens exponentially. Third is spectroscopy, the ultimate chemical detective. The James Webb Space Telescope, with its unparalleled infrared sensitivity, will be the star player here. It will search for absorption and emission lines from a suite of molecules: water, carbon dioxide, carbon monoxide, cyanogen, and more exotic species. The key will be the ratios. Are the CO2 levels still dominant? Is there any evidence of complex organic molecules or, in the most extreme speculation, spectral lines that correspond to no known natural compound? The spectroscopy will provide the chemical context for whatever activity, or lack thereof, is observed. Running in parallel to the compositional and morphological studies is the continuous, ultra-precise work of astrometry. This is the unglamorous but utterly critical backbone of the entire investigation. Using networks of radio telescopes like ALMA and the Very Long Baseline Array, VLBA, and optical telescopes with advanced adaptive optics, scientists will be tracking the position of 3i Atlas's nucleus with an accuracy down to a fraction of a millionth second. The question they need to answer is simple yet profound: is it where it's supposed to be? The gravitational model of its orbit, which now includes the inferred, non-gravitational acceleration from the perihelion period makes a very specific prediction for its location on December 19th and the days surrounding it. If the object is precisely on that new predicted track, it confirms that the acceleration was a real, one-time event linked to its close solar pass. If it has deviated further from the predicted path, it means the acceleration is ongoing, a continuous thrust that defies explanation. If by some miracle it is back on the pure gravitational path, it would suggest the initial measurement was a colossal error. The astrometric data is the anchor that ties all the other observations to physical reality. It is the hard numbers that will either validate the anomaly or expose it as an illusion, and the teams involved know that the weight of the entire investigation rests on the flawless execution of their measurements. Beyond the primary observational campaigns, several teams are pursuing what are considered long-shot investigations, avenues of inquiry that have a low probability of success, but a potentially earth-shattering payoff if they find anything. One such effort is a dedicated radio astronomy campaign. While natural comets are not strong radio emitters, an artificial object might leak radio frequency radiation from power systems, internal computation, or active instrumentation. Telescopes, like the Green Bank Telescope in West Virginia and the Allen Telescope Array in California, will be listening to 3I Atlas across a wide band of frequencies, searching for any non-thermal structured radio emissions that stand out from the background. Cosmic static. Another long shot involves searching for laser or other optical communication pulses. A highly advanced probe might use tight beam lasers for data transmission back to its point of origin, and while the chance of intercepting such a beam is infinitesimally small, it is a possibility that SETI researchers are taking seriously. Finally, there is the search for associated objects. Could 3I Atlas have deployed smaller subprobes? Are there any tiny, previously undetected fragments traveling in formation with it? Deep, high-resolution imaging will be used to scour the space around it for any companions. These efforts represent the frontier of the investigation, acknowledging that if the object is truly artificial, its methods of operation and communication would be so advanced that we must cast the widest possible net, using both established science and speculative imagination to have any hope of understanding it. The story of 3I Atlas has long since escaped the confines of academic journals and observatory control rooms. It has become a global cultural phenomenon. Major news networks have prepared special segments with countdown clocks and panels of experts ready to interpret the incoming data. Social media is ablaze with speculation, analysis, and, inevitably, wild conspiracy theories. The hashtag #3I Atlas trends worldwide. The public, for perhaps the first time since the Apollo missions, is collectively and keenly focused on a single, unfolding event in space science. There is a palpable mix of excitement and anxiety. For many, the possibility of discovering something truly alien is exhilarating, a chance to finally answer the ancient question, are we alone? For others, the implications are deeply unsettling. The concept of a non-human intelligence, one capable of sending objects across the interstellar void, challenges deeply held religious, philosophical, and existential beliefs. Governments, while publicly supportive of the scientific endeavor, are privately conducting their own risk assessments. The planetary defense implications are being quietly modeled in secure facilities. What is the protocol if the object were to make another, more disconcerting course correction? While the scientific community remains rigorously objective, the world watching from the sidelines is a maelstrom of hope, fear, and wonder, all waiting for the same set of images and data to provide clarity or to plunge us into a deeper, more profound mystery. In the first week of December, the initial data begins to trickle in. The object is now close enough for even moderate-sized telescopes to gather useful data, and the first processed images from key observatories are released. The atmosphere in control rooms is tense. The first set of optical images from a telescope in Hawaii appears on the main screen. There is a collective leaning forward, a holding of breath. The image is clear, the processing sharp. The nucleus of 3I Atlas is a bright pinpoint object, and surrounding it is a coma. It is there. But the immediate expert analysis is one of profound confusion. The coma is present, but it is compact, contained. It does not show the massive, billowing structure that would be expected from a body that had just undergone a cataclysmic outgassing event. It is, in the words of one astronomer on the live stream, anemic. It's active, but it's not violently active. This is the first concrete data point, and it is ambiguous. It does not immediately confirm the terrifying scenario B, no debris, but it certainly does not support the comfortable scenario A, massive debris. It sits in the uncomfortable, murky middle ground of scenario C. The mystery has not been solved. It has simply sharpened its focus. The photometric data from the first few days shows a similar story. A slight, steady brightening consistent with its approach to Earth and the Sun, but no dramatic spike, no signature of a recent, massive ejection of reflective dust. The initial reports send a ripple through the global community. The scientific blogs and news outlets are cautious. 3I Atlas shows activity but not catastrophic levels, reads one headline. The waiting continues, but now with a new, more nuanced tension. A few days later, the first dataset from the James Webb Space Telescope arrives. This is the moment many have been waiting for. While optical images show structure and brightness, JWST's infrared spectrometers can see the chemistry. The data is complex, requiring hours of processing and analysis by teams of specialists. When the first spectra are finally presented at a hastily arranged virtual press conference, the results are, once again, deeply strange. The carbon dioxide signature is overwhelmingly dominant, just as it was before perihelion, confirming the object's fundamental alien composition. The water lines are still faint, reinforcing the dry nature of this comet. But there is something new. The spectroscopy reveals a surprisingly high amount of carbon monoxide, CO gas, in the coma. This is a highly volatile molecule that sublimes at very low temperatures. Its presence in such quantities suggests that the heat from the sun penetrated the nucleus, activating deeper, more volatile layers. However, the total production rate of all gases combined, when plugged into the rocket equation, still falls orders of magnitude short of what is needed to explain the 4 arcsecond positional offset. The chemical verdict is in 3I Atlas is outgassing, but it is not outgassing nearly enough. The propulsion, if that is what the acceleration was, is not accounted for by the visible chemical activity. The JWST data, instead of providing an answer, has widened the gap between observation and explanation. The pressure now shifts to the astrometric teams. The position of the object is now the final arbiter. December 18th, the day before closest approach. The astrometry teams from ALMA and the VLBA have been working around the clock, combining data from multiple sessions to achieve the highest possible precision. The lead scientist for the astrometry group is scheduled to give a briefing. The virtual meeting is packed with hundreds of astronomers, journalists, and agency officials from around the world. There are no fancy graphics, just a simple slide with 2 plotted lines on a graph. One line is the predicted trajectory based on gravity alone. The second line is the predicted trajectory based on gravity plus the non-gravitational acceleration from perihelion. And then there is a single bright red data point, the actual measured position of 3I Atlas as of 600 UTC. The room falls silent as the scientist speaks. The object, she says, her voice calm but firm, is not on the pure gravitational path. A murmur goes through the audience. It has continued to deviate, she pauses, letting the significance sink in. Furthermore, its current position is consistent with the model that includes the non-gravitational acceleration. The offset is real. The acceleration was real. And our current observations of its coma and gas production remain insufficient by at least a factor of 50 to explain it. The statement is seismic. It is the official peer-reviewed confirmation of the 10th anomaly. 3I Atlas has, without a doubt, performed a maneuver that, according to known physics, should have required it to tear itself apart in a spectacular display, and it did so with only a faint, polite whisper of activity. Scenario B is now the operating reality. The conservative natural comet explanation has effectively been ruled out. The scientific world is now officially in uncharted territory. The announcement sends shockwaves through the global community. The carefully maintained language of scientific caution begins to crack. Headlines are no longer tentative. Interstellar object defies known physics. 3I Atlas mystery deepens no explanation for movement. The story dominates front pages and leads every news broadcast. Within the scientific community, a paradigm is shifting in real time. The focus of inquiry immediately pivots. The question is no longer, is this a weird comet? But has become, what then is it? Emergency symposia are organized. Prestigious journals fast-track publications on the implications. The two main competing hypotheses now have to be openly and seriously debated. The first is the exotic natural mechanism hypothesis. Proponents argue that we are seeing a new type of physics, perhaps related to the object's mysterious composition. Could its carbon dioxide-rich interior be interacting with solar heat in a way that produces a highly efficient, low-mass loss form of thrust? Is there some quantum or thermodynamic effect we have never observed? This group is scrambling to develop new models to find any loophole in the conservation of momentum that could account for the observations without invoking intelligence. The second, and now vastly more prominent hypothesis, is the non-natural origin or artifact hypothesis. This is no longer a fringe idea. Respected scientists, while still avoiding the word alien, are now openly discussing techno-signatures and potential non-human technology. The conversation has moved from if to how would we know for sure. The burden of proof has dramatically shifted. The object's continued existence and its suite of anomalies are now the evidence that demands an explanation, and the default natural explanations have failed. Harvard astronomer Avi Loeb, long a proponent of taking the artificial hypothesis for interstellar objects seriously, finds his once lonely stance suddenly validated. In a flurry of media appearances and a new paper published within days of the astrometric confirmation, he lays out a coherent, evidence-based argument. We must apply the same principles of scientific reasoning we use in other fields, he argues. If you walk on a beach and see a smooth, symmetrical stone, you might think it's natural. But if you see a smartphone, you immediately recognize it as technology, not because you understand its inner workings, but because its form and complexity are unmistakably the product of design. 3I Atlas, with its combination of anomalous trajectory, anomalous composition and now confirmed anomalous acceleration, is displaying a suite of complexities that, in their totality, point toward design. He systematically addresses the counter-arguments. To the claim that it's never aliens, he counters, that is an argument from history, not from data. Every new phenomenon was once unknown. Pulsars were initially labeled LGM1 for little green men until a natural explanation was found. But in this case, the natural explanations are failing. To the argument that interstellar travel is too hard, he points to humanity's own Project Icarus II, a solar sail mission that is now on an interstellar trajectory. We're already doing this with our primitive technology. A civilization 1,000 or 1,000,000 years more advanced would find it trivial. Loeb's voice, once dismissed, now frames the scientific and public discourse. He advocates for a new, proactive mission, not just to observe the next such object, but to intercept it. The confirmed anomalies of 3I Atlas have ignited a fierce and urgent debate about the future of interstellar object studies. The consensus is clear. We cannot let the next one pass us by. The concept of a rapid response interstellar interceptor mission, once a pipe dream, is now a top-level discussion point at space agencies. The goal would be to have a spacecraft equipped with advanced sensors, cameras, and particle analyzers in a ready state, capable of being launched on short notice when the next hyperbolic object is detected. This interceptor would need to be fast, capable of matching velocities with the visitor, and would perform a close flyby, perhaps even deploying impactors to sample the material or landers to study the surface directly. The scientific payload would be specifically designed to look for evidence of technology, refined surfaces, geometric shapes, isotopic ratios indicative of industrial processing, or internal structures. The European Space Agency's Comet Interceptor mission, already planned for a future launch, is suddenly seen as a crucial prototype. But scientists are now calling for a dedicated, well-funded program specifically for interstellar anomalies. The lessons of 3I Atlas are that remote sensing, while powerful, has its limits. To truly understand an object like this, you need to get up close, to smell it, to taste it, to touch it. The imperative is no longer just curiosity. It is a fundamental need to understand what shares our cosmic neighborhood. As the initial shock of the scientific confirmation subsides, a deeper, more profound reckoning begins to take hold in the public consciousness. The potential that 3I Atlas is an artifact forces humanity to confront its place in the cosmos in a way no radio signal ever could. A signal is ephemeral. An object is tangible. It is a piece of physical reality that is not of this earth and potentially not of natural origin. This realization triggers a philosophical and existential earthquake. The Copernican principle, the idea that we are not in a special place in the universe, is challenged in a new way. We may not be at the center, but we may also not be alone, and worse, we may not be the most intelligent actors on the cosmic stage. The great silence of the universe, which SETI has encountered for decades, is reinterpreted. Perhaps the silence isn't because no one is there, but because they are not communicating in the way we expect. Perhaps their presence is felt through silent, stealthy probes, studying stellar systems with the quiet efficiency of a field biologist observing an anthill. This is a far more disquieting prospect than a friendly radio welcome. It implies a universe that is not necessarily hostile, but is vast, old, and largely indifferent to the affairs of a young species on a minor planet. Our entire narrative of history, theology, and purpose is suddenly contextualized within a framework that is immeasurably larger and more mysterious. The implications of 3I Atlas quickly spill over from science and philosophy into the hard realities of geopolitics and economics. The confirmation that interstellar objects can possess such bizarre and technologically suggestive properties triggers a new space race, but one with a very different character. National security agencies worldwide take a sudden, intense interest in near-space object tracking. The budget for planetary defense initiatives sees proposed massive increases. The ability to predict and potentially interact with such objects is framed as a matter of national and planetary security. Simultaneously, the private space industry sees an unprecedented opportunity. Companies like SpaceX, Blue Origin, and new startups begin drafting concept studies for interstellar interceptors, sensing both government contracts and immense public interest. The economic potential is not in mining 3I Atlas, but in the technology developed to reach it and its successors. The spin-off technologies in propulsion, autonomous navigation, and compact sensor suites would be revolutionary. The very existence of this mysterious object acts as a catalyst, accelerating humanity's expansion into the solar system. The Moon and Mars are no longer just destinations. They are potential staging grounds for deeper forays, platforms for larger telescopes, and faster spacecraft to hunt for the next visitor. 3I Atlas, a silent, passive traveler, has inadvertently become the most powerful engine for human spaceflight advancement in a generation. As 3I Atlas recedes into the dark, continuing its endless journey out of our solar system, its legacy is cemented. It leaves behind a transformed scientific and cultural landscape. In astronomy, it marks the definitive end of the era when interstellar objects were mere curiosities. They are now primary targets, objects of intense scrutiny that hold the keys to understanding not just other star systems, but potentially other intelligences. Every new survey, every new telescope proposal will now include the search for the next 3I atlas as a core objective. The atlas criteria, a specific set of anomalous properties including non-gravitational acceleration without sufficient mass loss, unusual composition, and improbable trajectories, becomes a standard filter in data analysis pipelines. The object's story is taught in classrooms not as a solved problem, but as an open question, a lesson in scientific humility and the courage to follow evidence into uncomfortable territories. It becomes a cultural touchstone, a symbol of the vast, unknown, and potentially inhabited cosmos. The name 3I Atlas no longer refers to just a comet. It becomes synonymous with a fundamental shift in human consciousness. The moment we began to seriously consider that we might be living in a populated galaxy, one where visitors, whether natural or artificial, drift through our celestial neighborhood with silent, enigmatic purpose. The final act of the immediate 3I Atlas investigation is the creation of a monumental centralized data archive. Every single observation, every image, every spectrum, every astrometric measurement, every radio scan from its discovery in July 2025 to its final faint detection as it moved beyond the orbit of Jupiter in early 2026 is collected, calibrated, and made publicly available. This archive, hosted jointly by NASA and the ESA, becomes one of the most downloaded and analyzed datasets in the history of astronomy. For decades to come, graduate students and senior scientists alike will run new algorithms, test new physical models, and apply new statistical techniques against this treasure trove of information, hoping to find some subtle clue that was missed in the initial feverish analysis. The archive is a time capsule of a mystery, a permanent challenge to future generations of scientists. It ensures that the case of 3I Atlas remains open, a perpetual invitation for a sharper mind or a new technology to finally solve the riddle of the object that moved without a cause. In the years following the 3I Atlas event, a new normal emerges in planetary astronomy. The launch of the Vera C. Rubin Observatory and other next-generation surveys begins to detect interstellar objects with a frequency that astonishes scientists. They are not rare. We were just blind to them. And among this new population, a pattern begins to emerge. While most are Borisov-like, behaving as expected, a small but statistically significant percentage, roughly 1 in 20, exhibit one or more of the Atlas criteria. Some have the strange carbon dioxide-dominated chemistry. Others show the unusual polarization. A few even exhibit small but measurable non-gravitational accelerations that are not fully explained by their observed outgassing. No single new object is as comprehensively anomalous as 3I Atlas, but the collective data paints a picture of a diverse interstellar population where a certain fraction consistently defies easy classification. This is in many ways more revolutionary than 3I Atlas alone. It suggests that what we witnessed was not a unique fluke, but a category. There is a family of interstellar objects that do not play by the standard rules. The hunt is no longer for one mystery object. It is for an entire class of enigmatic travelers, and understanding them becomes one of the grand challenges of 21st century science. With a growing sample of anomalous interstellar objects, the scientific community begins to refine the competing hypotheses with more nuance. The exotic natural camp gains traction by proposing a specific, testable mechanism, sublimation-driven anisotropic jet thrust. They theorize that objects like 3I Atlas possess a unique internal structure, a porous, low-density matrix of carbon dioxide ice interspersed with pockets of more volatile ices like carbon monoxide, all sealed beneath a thin sintered crust. When heated, the sublimating gas does not escape randomly. Instead, it finds pathways through the matrix, becoming channeled into a small number of highly collimated supersonic jets. This would produce a vastly more efficient thrust-to-mass loss ratio than the diffuse, dusty outgassing of a water-ice comet. The model is complex and requires very specific formation conditions, but it is a serious, peer-reviewed attempt to explain the anomaly within the bounds of known physics. It becomes the leading natural explanation, a testament to the ingenuity of scientists when faced with a paradigm-challenging puzzle. Concurrently, the artifact hypothesis evolves from speculation into a rigorous subdiscipline, the study of non-terrestrial technosignatures, or NTTs. Researchers develop a quantitative framework for assessing the likelihood of an object's artificial origin, moving beyond simple anomaly counting. This framework assigns probabilistic weights to different types of evidence. An anomalous trajectory might have a low weight on its own, but when combined with anomalous composition and anomalous acceleration, the combined probability multiplies. The framework also outlines what would constitute smoking gun evidence: the detection of internal cavities via radar, the observation of non-random information-rich patterns in light curves, or the definitive identification of manufactured isotopes or materials. This formalizes the search, allowing scientists to rank future interstellar discoveries by their NTT potential and allocate resources accordingly. The study of 3I Atlas becomes the foundational case study for this new field, its data serving as the benchmark against which all future candidates are measured. Looking back from the vantage point of the future, 3I Atlas is seen not for the mystery it failed to solve, but for the revolution it catalyzed. It was the spark that ignited humanity's serious, sustained search for non-human technology in our cosmic backyard. It forced a collaboration between planetary scientists, astrophysicists, and SETI researchers that had never existed before. It drove the development of faster spacecraft, more sensitive sensors, and more intelligent AI to scan the skies. The first dedicated interstellar interceptor mission, launched in the late 2030s, is named Project Atlas in its honor. The object itself, a silent, dark speck receding into the galactic disk, carries no knowledge of the intellectual and technological earthquake it triggered on a small world orbiting a modest star. It simply continues its journey, a permanent enigma sailing the cosmic ocean. And so, we are left with the unanswered question, a doorway that 3I Atlas opened and which can never be closed. Was it a natural object of a type so exotic it teaches us about the incredible diversity of cosmic chemistry and physics? Or was it a relic, a probe, a message in a bottle from a distant shore of the galaxy, a silent witness to our own emergence as a technological species? The data we have allows for both possibilities, and the debate will likely continue for centuries. The true legacy of 3I Atlas is this enduring question. It serves as a permanent reminder of the limits of our knowledge and the boundless potential for discovery that lies just beyond our current understanding. It transformed us from a species that wondered if we were alone into a species that actively, systematically searches for its neighbors, knowing that the evidence might not be a signal, but a traveler passing silently through our home, leaving behind only a trail of tantalizing clues and a transformed view of our place in the universe. The story of 3I Atlas is not over. It is simply waiting for the next chapter to be written by us as we journey out to meet the next visitor.